Hi everybody, this is Mr. Nardelli. I wanted to go over some of those problems for statistics from, I believe it was chapter 2. I'm not exactly sure, but it's the one, there were actually two problems. Now, what I have done, and by the way, the first one is problem 4. I've cut and pasted them so that we can see both graphs together. I believe when you go through it, you have to scroll up and down because the graphs are quite big. So we start off, and again, when you see these things, don't panic. It could take 2, 3, 4, or more times reading through it. If you need to do that, go ahead and do that. So it says, look at the histogram below, which shows mileage in miles per gallon for a randomly selection of older passenger cars. So it basically shows us that as miles per gallon increase, here's the frequency or the number of cars. So we could see that between 8.5 miles per gallon and 12.5 miles per gallon, there were 8 cars. And then it jumps to 13, and then it drops, and it jumps, and then, the one with the really, really good gas mileage is only one of them. So the first question, which I have the answer there for you, it asks, is it bimodal? So when you look at those answers, you see you've got yes and no choices. So you have to decide, is it bimodal? Bimodal means 2 lumps. I can't draw it, but if you could draw a picture here, you would see there's 2 bumps. Okay, so yes, it's bimodal. So there's your chance. You can cut out this no and this no answer. You're now with one fell swoop down to 2 choices. So you have to choose whether it's yes because it has 1 peak or yes because it has 2 peaks. Well, you just described or just determined that bimodal means 2 peaks, so it's bimodal. It has 2 peaks. Answer number 3. Okay, that one didn't give you any fits, but this one sure did. Jose looked at the raw data and discovered that the 54 data values included both the city and highway mileage for 27 cars. So here are the 27 cars. If you add that up, you'll see it becomes 27. So that includes city and highway. And if you know anything about cars, city driving tends to get less gas mileage than highway driving. So it says he used the city mileage for the 27 cars to make this histogram. So what he did is he took this histogram that included city and highway driving and pulled the data out that we can't see and made one for just city. So he found out that the city driving, that you can see 24.5 miles per gallon is the highest. So there were only 4 ranges. And if you add these up, you get, I think he said 27. I think it was, yes, because the original one was, I believe, 54. Yeah. So 27 of them are history. So it says, use the information and the histograms shown above, construct a frequency table for the highway mileages of the same use, and use these boundaries. Okay, so what we're going to have to do is we want just the highway mileage. This is highway and city. This is city. So basically we need this minus this. So we first look at 16.5 to the 20.5 range. 16.5. Total amount, there are 8. So we looked at that same range of city. There are 5 here. So we do 8 minus 5, giving us 3. I'm going to put, sorry about that. I'm going to put my answers in like this. And sorry about that. So, 3. Now we go to the 20.5, 24.5 range. So, total, there's 2. Of city, there's 1. 2 minus 1. is 1. Okay, I'm going to put that answer here. It's 1. Okay, now the 24.5 range to 28.5 range. There's only 2 total. So we go 24 to 28. There's none over here, the city range. So that's just 2. Well, it's 2 minus 0, giving you 2. Sorry about that. 2. Our next range right here, and you can kind of see what's going on here. The city mileage does not have these ranges. So this range, and this range are not shown here. So we can actually come up here and say to ourselves, the 28.5 to 32.5 range is 13 minus 0, or 13. I gotta open up this box. The next range, 32.5 to 36.5, is 7 minus 0, or 7. And the last range is 1 minus 0, or 1. So it was a matter of looking at the graph and actually reading this stuff. And it took me a couple times. So again, look at this and don't freak out, but read it once, twice, 3 times, as much as you can. Okay, now what I'll do is scroll to this one. And what I did is I took everything there and crunched it up so that we're all on one page. So I looked at this, the Ogives, and I thought, was that supposed to be Ogilvy or Olives, or was that a misprint? So I just Google searched it, and I found out something. Wow, I've never heard of that term. But this is a definition of an ogive. It's a graph that shows the cumulative distribution function, or cumulative frequency distribution. It's also called a cumulative frequency. So what it means is, as you move farther to the right, the previous number is added. So as we read this, the ogives shown are based on data collected in the U.S. and show the average annual personal income per capita for each of the 50 states. 50 states, that's important. The data are rounded to the nearest thousands of dollars. So if you figure something out and you get 1,032 cents, you would round that to $1,000. That's what that means. So as we move closer here, per capita, there are 0 states with $27.5 thousand per capita. As we move to 32.5, there's 15. As we move to 37.5, there's 34. So you'll notice as we move higher, the number of per capita income gets higher. But as you look at this graph, you see it starts getting higher or less, I guess you could say. I mean, even jumping from here to here, it just jumps one state. So it's cumulative. So you see, here's our 50 states when we added them all together. If we wanted to know how many states had a per capita income of 37.5 or lower, 34 of them. If we wanted to say how many states have a per capita income of 52.5 or lower, well, that's all of them. Over here, we have it in percentages. So the 32.5, 30% of the states have a 32.5 per capita income. When, if you're talking about 52.5 or lower, 100% have it. So you see that correspondence right there. 50 out of 50 is 100. 49 out of 50 is 98. You get the idea there. Okay. All kidding aside, we get to this one. It says, how were the percentages shown in graph 2 computed? These are choices that I think are kind of wacky. So one strategy I use, I look at these and I try to start reading and see where the words change. You'll notice everything is exactly the same up until this word, multiplying and dividing. So everything's the same before that. So you're basically saying to yourself, am I going to multiply or divide something? Well, if we looked at this before, we said to ourselves, 98%, well, let's go to this one. 100% is 50 divided by 50. Well, that comes out to 1 or 100%. We can plug in our calculator here, over to the number here and say 49 out of 50. 49 divided by 50 gives us 98%. So what we did was take this number and divided it by the total. So as we look down, numbers 1 and 2 are out. So we have to decide between 3, 4, and 5. Now think about what you just did. You did 49 divided by 50. So the percentages were computed by dividing each of the cumulative frequencies by 50 and converting to percents. Okay, that sounds like the answer, but let's knock out the other two just to be sure. Dividing the cumulative frequency by 100, then converting to decimals. No, we don't have 100 states. Dividing the cumulative frequency by 50 and converting them to fractions. Nope, there's no fraction. It's percentage. So in that case, we can see the answer is number 3, or the third one. That's my way of filling it in. Sorry. Okay. Now, it asks us, how many states have average per capita income between 42.5 and 52? Oh, no, I'm sorry. Let's go to number B, letter B. How many states have an average per capita income less than 37.5? So we look here and we say there's 37.5. How many are here or less? Well, it tells us there are 34 right there. So putting my little box in, let's just put it over here. How about that? There's 34. Now, letter C says, how many states have an average per capita income between $42.5 and $52.5 thousand dollars? So between 42 and 52. So we look at that 43 and 50, so we have to do 53 minus 40, giving us 7. What I'm doing here is just cheating a little. 7. Now we go to the percentage, because you'll see we have to jump over here. What percentage of states have an average per capita income more than 47.5? Okay, so here's 47.5, that's at 98%. Here's the 100, so we have 100 minus 98, giving us not 7, but 2. There's only 2. Okay, so that's how you solve that one, and yes, it is very tricky, and it's kind of ominous, and I'll admit, a little bit scary. So take your time with these. If you have any more questions, screenshot it and send it to me. I'll create another video. I'll also, at the next class, start pulling stuff up from my computer so you don't have to see my scary looking graphs. Thanks. Bye-bye.